Dealing with the metric system. Very, very critical because with science or with chemistry, we're going to be working with the metric system. We don't really work with the English system a whole lot. We're going to work with conversion factors between the two, but universally the common language when it comes to measurements is actually the metric. So the metric system is based upon the power of 10. And so I see 1 meter is equal to 10 decimeters, which is the same as 100 centimeters, which is the same as 1,000 millimeters. The beauty about this is we're just moving the decimal. We're never actually changing the number. For example, 1 foot equals 12 inches, or 3 feet equal 1 yard. So the number is always changing. The beauty about this, once again, the number never changes. We're just moving the decimal. So what's very valuable is we work with this. We'll work with prefixes and we work with base units. So some base units we'll actually work with would be stuff like length. We'll be working in measurement of a meter. These are not the System International units, but these are common ones we will actually use in the laboratory. Mass, we'll use gram, which is G. Volume, we commonly use in liter or milliliter. Time, we'll use second, and energy, we'll get to joule. We will get to that into the second semester. But the prefixes are very valuable. You put into memory. So I want you to memorize this. And I have three things here. I have a prefix, for example, tera. The symbol of that prefix, so the symbol for tera is T. And then I want you to understand its multiplier, 10 to the 12. Okay, and that just means a trillion. So you have 1 with 12 zeros after it is a trillion. Then we get to a giga. So the giga is capital G, and that's 10 to the 9, so 1 with 9 zeros after it, or the same as a billion. We have mega, which is capital M, 10 to the 6, which is the same as a million. Then we go lowercase. We get the kilo. This is K. This is 10 to the third, which is 1,000. You have 1 with 3 zeros after it. Hecto, lowercase h, 10 to the second, which is 100. And then you have deca, DA, which is 10 to the first, which is just 10. I shouldn't say tens. I should say 10. Then we get to our base unit. And this is kind of the base units we talk about. M is for your meter, G is your gram, L is your liter, S is your second, J is your joule. Now, to adjust any one of these measurements, all I have to do is put a letter in front of it. I put a T, I could have a terameter, or I could have a gigameter, a gigagram, a megagram, a kilogram. Very commonly you see kg, which is kilogram of 1,000 grams. But not only do we have prefixes that get larger, we also have prefixes that get smaller. So let's move to the smaller side. Now, below our base unit, deci, which is 10 to the negative 1, that's a tenth of something. Centi, 10 to the negative 2, which is a hundredth of something. Milli, lowercase m, which is 10 to the third of something, a thousandth. Micro, this is a kind of like a U with a tail on it. So it's a millionth of something, and nano, n, which is a billionth of something. That's just, we'll go down to pico, lowercase p, which is 10 to the negative 12, which is a trillionth. And commonly what you'll see us staying primarily within is anywhere between commonly the 4, the kilo, all the way down to 9 milli is commonly where we'll play around with when we're working with these prefixes. But right now you need to know all of them. So let's take a different look at this. If we were to lay this out linear, we would see then to the left are very large numbers, to the small we are to the right we have very small numbers. So in this situation we have deca, which is a 10, hecto is 100, kilo is 1,000, and then we have million, billionth, trillionth. The little numbers are to your right. So if we want to think about your decimal place right there in the middle, and we move our decimal, again, we have a deci, centi, milli, we're getting smaller. So anything to the right is greater than 0, or left excuse me, is greater than 0. Anything to the right is actually less than 0. Another way to look at it is this. When I say a mega is a million, it's that. Now why, I'm just going to write it out as 1 times 10 to the 6. Kilo is 1,000, or 1 times 10 to the third. Hecto is 100, or excuse me, 1 times 10 to the 2. Deca, 1 times 10 to the first, and then 1. My deci, now getting smaller, is a tenth of a hundredth of a thousandth, and of a micro is a millionth. Now, why are these important? Well, these multipliers can be used as what we call conversion factors, and we're going to start getting into conversion factors a little bit. Right now, this is a metric to metric conversion. So, for example, if I said a megameter, you would say, well, the multiplier for mega is 10 to the 6. So, 1 megameter is the same as 10 to the 6 meters. We know mega and 10 to the 6 are the same thing. So, we can actually use them interchangeably. A tera is 10 to the 12th. A kilo is 10 to the 3rd. So, on one side of the equal sign, I have a letter. On the other side, I have its numerical value. And so in this situation, we become a conversion factor. That means these two numbers are equal to each other. A micro is 10 to the 6 meters, a pico is 10 to the negative 12 meters, and milli is 10 to the negative 3 milliliters. Now, converting with the metric system and dimensional analysis, converting the base unit by canceling units, the top cancels out the bottom. We're going to place the multiplier with the base unit, okay? Place the multiplier with the base unit. Well, I gotta get that explained as I go through this, and place a 1 in front of the unit with the prefix. So the number goes in front of my base unit. If it was a prefix in front of my base unit, then I just put the number 1 in front of it. Then I enter the multiply on the calculator, use again my exponent key in that process. So 10 to the negative 6, what I actually do is 1, and then exp, then negative 6 is how I'd enter that in my calculator. You would not enter the situation as 10. You don't enter 10 in your calculator ever. So if I had a situation, your example, I say how many pigs are in 2 barns. So in this situation, I know my conversion factor. I'd give this to you. Say, well, 1 barn equals 6 pigs. We're just making something up. So 1 barn equals 6 pigs. That's a conversion factor. So I can put 1 barn over 6 pigs or 6 pigs over 1 barn. It doesn't matter. It's like saying 2 is equal to 2, right? If 2 is equal to 2, then I can put 2 over 2, or I can flip it, put 2 over 2. It doesn't matter because they're equal to each other, and that's what makes a conversion factor. Now, I look at this and I say I have 2 barns. Well, that means I want my barn to cancel out. So in this situation, my barn is going to be down here. The rule of thumb is opposites cancel. The straight across, I square or cube something. I don't want to ever do that. I want to cancel out. The cancel out, they must be opposite. So I put my 1 barn down there and my 6 pigs up there. That's my conversion factor. My barns cancel out. I multiply. Then all I do is multiply 2 times 6 and I get a total of 12 pigs. Again, we would not do it this way because barns and pigs do not cancel out. Therefore, I'd end up getting barns squared per pigs, and that's not what I'm looking for. I want to actually move from barns to pigs in my actual question. So as we work with this, I have 3.6 nanometers. So if I look at 3.6, now I'm going to put it in scientific notation. And I explained this to you a little earlier. Let me explain this to you again. So I'm going to put, first of all, nanometers to meters. My nanometers cancel out. That's my rule of thumb, and I end up in meters. So opposite cancel out. So I know I have them set up correctly. Now the rule of thumb is I put a base unit. I put 1 in front of the prefix, and I put the base unit in front of the actual base unit. Sorry, the multiplier in front of the base unit. Excuse me. Now, in front of that 10 to the negative 9 is an understood 1. So really my 3.6 times 1 divided by 1. So my 3.6 I can carry all the way over. And then all I have to do is work with my exponents. And I know the rule of thumb is this. When I multiply my exponents, I add them. So 0 plus negative 9 is negative 9. And I have a new unit, which is meters. So my next one, I have 55.6. What I'm going to do, first of all, is I'm going to put it in scientific notation. So 5.56 times 10 to the first. So now I'm going to go from grams to teragrams. My grams are opposite, they cancel out, and end up in teragrams. That's what I want, because it tells me convert grams to teragrams. Next, my base unit, or my prefix, always gets 1. I don't care if my prefix is the numerator or my prefix is the denominator, the prefix always gets 1. The base unit always gets the multiplier of the prefix. So it's not just some random number. Tera is the same as 10 to the 12th. Now in this situation, I know that 10 to the 12th is the same as 1 times 10 to the 12th. So my 5.56 times 1 divided by 1 is still going to be 5.56. This is helpful when you work with the metric system, because remember, the understood for the metric system is commonly 1 times 10 to the 12th. Or 1 times 10 to the negative 9. Before all the multipliers, the number before the multiplier is always that understood 1. So in this situation, then I always have to deal with the exponent. So now 10 to the first is divided by 10 to the 12. So remember with exponents we actually subtract them. So 10 to the first minus a 10 to the 12, it's like adding a negative 12, which ends up being negative 11. Now working with this problem, I'm going from centimeters to megameters. So I'm going to teach you to go to your base unit first, which is meters. But first of all, before I'm going to do this, since I am working with multipliers and there's always an understood 1 in front of the multipliers, I'm going to make things easy, and you can only really do this easy within the metric system. So I have 575, so I'm going to change that to scientific notation first of all because I know I'm going to be working with exponents. So then I put in my units. So I'm in centimeters, I want my centimeters to cancel out, I want to go home first, so I'm going to go back to meters. And then from meters, I'm going to head about the megameters. And then we go through our rules. All the base unit with the prefix gets 1. But first of all, I double check, make sure everything cancels out. Now, my first one, centi, gets 1, and the multiplier for centi is 10 to the negative 2, so I put that in front of my meters. For my mega gets 1, and the multiplier for mega is 10 to the 6. Now I realize, once again, in front of my multipliers, in front of 10 to the negative 2, in front of 10 to the 6 is a number 1. So 5.7 times 1 times 1 divided by 1 is still 5.75. So then I realize all I have to work with are my exponents. And so I have 10 to the second times 10 to the negative second divided by 10 to the 6. So first of all, as I multiply, I add. So 2 plus negative 2 is 0. And then I'm dividing, so I'm going to subtract 6, which is like adding a negative 6. So in this situation, my answer ends up being negative 6. And the units, my new units now are megameters. The next one, I have 0.456 decagrams. I want to change it to picograms. So I'm going to put my 0.456 in scientific notation first of all. Then I'm going to go from decagrams to grams, and from grams out to picograms, making sure I did it right. My decas cancel out, my grams cancel out, and up in picogram. Then I didn't have to work with my individual conversion factors. Deca has 1. The multiplier for deca is 10 to the first. Pico has 1. The multiplier for pico is actually 10 to the negative 12. So I know my 4.56 times 1 times 1 divided by 1 is still 4.56. So let's focus on the exponents. So I have 10 to the negative 1 times 10 to the first. So I'm going to add them. So negative 1 plus 1 is 0. Now I'm going to divide by 10 to the negative 12, so I'm now going to subtract them. So 0 minus a negative 12 is like adding a positive 12. So it's 4.56 times 10 to the 12, and the new units are now picograms.